Hey everyone, my name is Dave. Welcome to the NTDRacing Speed Shop. I'm really excited today. I get to test Harbor Freight's Vulcan ProTIG 205 dedicated TIG welder, and I'm going to be using this on the build of our new desert race vehicle called Trooper, which is a VW Bug. We're converting it into what's called a Class 11. You're going to want to stay tuned for that. But today I've got a smaller project I have to do, and I'm going to use this and I'm going to compare it to my Miller Dynasty 200. I've been using this welder for about 20 years. Is there a chance that the Harbor Freight can replace the Miller? Well, it happened before. I had a chance to test out the Vulcan Omni Pro 220, a multi-purpose welder. It does MIG and it does TIG, and it does MIG so well, I got rid of my Miller MIG welder, and I use this all the time. So today we're gonna see how well their dedicated TIG welder works. But first, let's go ahead and open the box and see what's inside, and then we're gonna put it to work. All right, I am totally impressed with this. As of the making of this video, this welder you can get from Harbor Freight as a non-member for $1,099. And if you're a member, it's like less than $1,000, which is a great deal, especially if it works well. We're gonna test that. But what's really interesting is all of the things that you get. When you buy other welders like a Miller, you aren't getting any of this stuff. You gotta buy your own torch. You gotta buy, a bunch of other stuff that doesn't come with this, and let's kind of go through some of those things. Let's start first on the back of the TIG welder. We'll work our way to the front. All right, again, some of the things that come with it. You got a 6-foot gas lead. They give you a regulator to set the gas flow. We'll set that up later. You're gonna use argon only on these machines. You have 2 power leads. One of them allows you to use the 115 out of your normal house, and the other one is gonna allow you to use one of these NEMA, I think it's called NEMA 6-50 plugs. They're pretty universal. I use the same thing on my compressor. My welder is over there. My Hypertherm with my Dragon A250, or my Razor Weld 45 on my Langmuir Systems Crossfire XR, all use the same connections. Let's go ahead and take a look at the front. All right, there's so much here to talk about. I won't be talking about this. They give you all the stuff you would need if you want to stick weld. I don't normally do that. And also, this would be a connector if you're putting on a CO2 bottle, but we're using argon, so I'm not exactly sure what that's going to be for. We can start going across here. This is the ground. The ground is a 10-foot lead to a really hefty ground. I like that. I would have liked it to be slightly longer than 10 feet, but you can change that if you want to, and you can put a longer one on. The next one over is your pedal. It comes with a 25-foot lead, and that's really nice because it'll let you put this thing just about anywhere in your shop. I look forward to testing this thing out and to see how well it controls the amperage of the weld. All right, so the next one over is the torch. Now, there are a few things different about this torch. It is nice that you get one to start welding with. It's a little bit different than what I am used to. If you take off this power lead here, you'll see that the gas goes right through the center of where the power comes in. And in most torches, what you have is you got the power, and then you have another port coming off where the gas comes through after the on and off switch. It goes through a 10-foot lead to a torch, 150 amp torch, I think is what this is. What's really cool though is they give you the whole torch. They give you all of the cups. They give you the tungstens. They give you the collets and all that for a couple different sizes in here. I usually use the 3/32, and that's what I have this thing set up on right now, which I'll be using to weld a little bit later. Now you can swap out the torches. If you wanted to stay with Harbor Freight stuff, I think you can go with the gas lens kit for 65 bucks, which is pretty good. That's what I would probably do. Or my favorite welder, I have one I think right over here, and I've also got one on my Miller over there, is CK, makes one of these exact same things. I think right now it's about $169 on Amazon or eBay. I'll put a link in the description below and you can find that. CK is my favorite, and it's a 25-foot lead, so it matches your pedal, so you can kind of move those things around together. Getting started on using all these things, what's really awesome is their quick start guide. I think is outstanding. It's really good. It'll get you going right away. But what is really good is a really well-written set of instructions. I'm super impressed by these. I just did a video where I talk about how to do, this is AC TIG welding for aluminum. This side is DC. I do mostly DC. I just did a video on how you do that, and all the steps I thought were really really well written. One of the things I think is interesting is this high frequency start, not something I'm used to. I usually do lift arc, and I've done it on most welders I've done. So I will be interested to try that out. And I will also be interested to see if I try lift arc, what happens? Does it work or does it not work? Because usually when I'm doing like tack welds, I like to do lift arc. So we'll see how that is. And then the top of the welder, it's got a bunch of stuff here, which I'm sure guys are looking at going, I understand that exactly. I do understand the duty cycle here. And you know, maybe the important one for guys out there is if you are TIG welding, 25% duty cycle at 205 amps. That means that in a 10-minute cycle, you can be welding for 2.5 minutes. It's got to be cooling for 7.5 minutes. But that's when you're welding at 205 amps. That's like 1/4 inch, 5/16. That's some pretty thick stuff that you might be welding. And then they have also here, what I really like is just the settings that they recommend. And what I usually weld is, you know, between 1/8 inch and maybe quarter inch plate. I've been welding with 330 seconds for a long time. I wasn't sure if I was right or not, but according to these guys, I was doing it all right. So when you turn the machine on with a switch right here, it comes up, and this couldn't really be any more simple, which I love about this machine, is you can select, you got DC TIG, which is your steel. You've got stick, which I've never used and I don't plan on using. And then you got your AC TIG, which is your aluminum, and all the settings for that. Going back to steel and something I talked to, your amperage, I'm gonna be welding 1/8 inch plate steel. I'm gonna be welding 3/16, so I'll be about 145 to about 180 when I weld those things. And then you can kind of select some of the parameters here as you kind of go across, like the pre-flow. When you pedal down, it's gonna flow gas for about a second before it starts at high frequency start. You can change the pre-flow, you can change the post-flow, because remember, you want to keep that hot welded piece shielded in argon gas after you're done welding to make sure it doesn't take on any of the bad things that happen with oxidation. And then you can turn on or off the pulse welding. I don't usually use that. I usually use the pedal for all the pulsing, but you can do the pulse welding. I'll probably practice that a little bit later on. And then there's all those things back to, so it really simple, very few options you have. And when you look at the aluminum stuff, I just found that I can't wait to try it. I won't be doing it in this video. So anyway, let's go ahead and get this thing set up. I got this project to do. Let me show you what that is, and then we'll get this thing set up and start doing some welding, and we'll test this against my Miller. All right, so this is the project that I'm working on right now. This is called Trooper. This is gonna be a Class 11 VW bug, and you won't believe it, but in 2 months, this is gonna be a full-on race car. It's gonna look beautiful, but we gotta get there first. One of the things I need to do is the roll cage is gonna come up here, and it is gonna terminate right up here on the beam. I need to build a bracket that goes on there, because you don't wanna actually weld to the beam, because you wanna be able to remove that in case you gotta replace it or something like that. So I'm going to make a die that I can bend some metal to fit around that shape, and I will be making the die to go in my Harbor Freight press that I have a press brake set up with Swag Off-Road. So in this video, we're gonna be welding some 1/4 inch, we're gonna be welding some 1/8 inch, maybe some stuff a little bit thicker. Here's a quick montage of how we got there. If you wanna see the full version of all the fabrication, it'll be right at the end of this video. I want it centered on that dot, and now it moves it so it's equal distance on that dot. All right, so you got to see that whole montage to get to these parts. And before I start welding on anything, I'm gonna go ahead and use a little bit of acetone and clean off the rest of the oils that are on the pieces. And that will remove a lot of the contaminants that might be on the metal. Anything you can remove for TIG welding is good, because any kind of contamination will kind of blow up your tungsten and make your weld look really bad. Let's take a quick look at the torch. Now, I've been welding with the ProTIG for the last couple of days, so I've been doing a lot of welding with this thing. And so I took off the cup that they had, which I didn't like it, because I've been welding with these gas lenses for a long time. I think it's up number 6, I don't know, something like that. I think the nozzle is about a number 6 or something like that. This is a gas lens. I'm still using the same tungsten that they had. I'm also using the same backside over here, but that just makes it so the gas comes out, I think, a little bit better as far as the shielding gas goes, and it makes this a little bit shorter, and you can also kind of put a stubby end over here such that you can kind of get into tight spaces. This will be the first piece I'm going to weld up here, just this half tube onto this 1/4 inch plate. This is 1/8 inch, this is 1/4 inch. I will be using about 170 amps of this weld. I'm also going to be, again, wearing these Vulcan Defender gloves. I think these were like 13 bucks from Harbor Freight. Amazing gloves. You can see how much I've been using these. I try to keep them clean, but I use them so much. These are my new favorite gloves. I'm going to get a bunch more pair of these. Let's go ahead and get to this weld. All right, so I think I mentioned that I had some concern about the high frequency start, but after having used it now for a couple days, I really like it. I'm going to go ahead and tack this thing on all 4 corners, and then we'll go ahead and run a bead all the way across. Once I hit the pedal, you'll hear the fan come on, so it'll be hard to hear me. Also maybe do some talking, but let's go ahead and start with some tacks. First, when I hit the pedal, you hear it first the gas go, you hear that high frequency buzz, and then it'll kick the arc out. Tack welds are always good when they're small, so this thing actually does a really good job, I think, of helping me make the tack welds. You know, as expected, anytime you tack anything, metal starts to move. It gets hot, it sets, then it cools and it moves. So I'm going to use this clamp to push that thing back down onto the piece so I can do these next tack welds. All right, and now we'll go ahead and run the bead all the way across. So there's a couple techniques for running the bead. One would be just what I'm doing right now, is you set temperature, you pedal down, and then you try to keep the puddle out in front of you, and then in a cadence I'm kind of feeding in this filler wire, and what that is doing is it cools the pull down right there, and that's how you get the stack of dimes. Another way you could do it is you could throttle the pedal and kind of get into a rhythm with throttling the pedal, and I like to do that especially if I'm welding round tube, or you can do the pulse arc, and I use that welding some of the other things on that I was working on, and I'll show you a video of that. And I didn't think I was going to be a fan of that, but I'm a huge fan, and you can see, man, that is a really nice bead that just laid down on there. So I think you'd be happy with that just about anywhere. All right, so on this other side, I want to kind of demonstrate like what I talked about as far as using the pedal and then pulsing the pedal. And one of the things I found about this, at first I wasn't sure if I liked it, this pedal. I just found that, you know, where it applies the amperage and where it takes the amperage off in my foot motion is different than what I had on my Miller. And so initially I didn't like it, but I got kind of used to it. I got a feeling that when I go back and try the Miller, I'm not going to like that one because it's not the same as I've been using on this one. And so now I'm like pedals up, so right now I'm going down and up, down and up, down and up, and every time I go down I'm feeding in a little bit of that filler right to the leading edge of that puddle in a little rhythm, so it makes it a little more difficult. But the nice thing about doing the pedal is that if you wanted to readjust your hands, you could stop for a second at low amperage, move everything, and then get back into it. You can kind of see again, that does a really nice job of creating a bead there. There, pretty good. It's pretty awesome. This time we got something bigger to weld. This is 1/4 inch plate. That's something slightly bigger. So I got this thing dialed all the way up to its maximum of 205 amps. I'm going to go ahead and just start with a small tack in here to get this thing to hold together. I don't usually like to weld with a magnet in place just because the magnet will pull the puddle all over the place. So I'm just going to get the tack in here just so I can get that magnet out of here. All right, now let's go ahead and see if we can lay down this bead across this 1/4 inch. looks pretty good. I can kind of tell that my tungsten is a little bit contaminated. I'm gonna go ahead and swap it out. Pretty much take that weld all day. All right, so Harbor Freight's Vulcan ProTIG 205. What is the verdict? It is an amazing TIG welder at any price. It just so happens that it is at a great price. And you're gonna see us using it a lot more as we continue the build of this Class 11 racer that we call Trooper. Now, I did use a lot of tools in the shop today. If you like any of those, check out the links in the description below to take you to our Amazon store. Costs you the same amount, but we do get a couple bucks from it, and it helps us pay for tires and all those things we gotta do to maintain a race team. Hopefully you found some value in this video, and if you did, we've earned your subscribe, and even more important, just because of the way YouTube works, if you don't activate notifications by clicking that bell symbol on your screen, then you may never see another one of our videos. Anyways, we sure hope to see you next week. Take care of yourself. To make what I need to make, I'm gonna have to cut a few pieces. Let's start with the easy one first. I'm just gonna make a rectangle. We are using, again, Fusion 360, and we're gonna be cutting on the Langmuir Systems Crossfire XR. We're gonna use the X and Y plane, which means we're gonna select front. So I'm gonna go over here to sketch. This just means I'm gonna draw some pictures. I'm gonna draw on this plane, which represents that X and Y plane you see over here in the right-hand corner. Z is the torch I control. All plasma cutters cut, I think all of them, on the X and Y plane. I'm just gonna hit hotkey R. When I see hotkey, I'm actually pushing a key on my keyboard, that's R, which brings up rectangle, and then I'll just make a rectangle. I know that it's 4.125 inches wide. I missed the 4.125 inches wide, and then it's gonna be 3 inches tall, or that'll be the size of this thing. Whenever it paints something blue, that means that it's enclosed and you can extrude it. But first, before I extrude it, I'm gonna make myself look really smart because I don't know, if this thing works, I'm gonna have it around for a while. So I'm gonna put nice little fillets on the end of this thing. And that looks good. I'm gonna hit extrude. And today I keep doing that. Today, we're gonna cut out a 1/4-inch plate. There's the first thing we're gonna cut. You saw once I extruded it, I went from having a sketch to bodies. So now this is body number 1. I can turn it off, I can turn it back on, but I'm gonna turn it off because we're about to make another sketch. Again, I'm gonna go back to sketch. I'm gonna stay on this same plane right here. And now we gotta do some a little bit of math and get out some measuring devices. Okay, so for the second piece we're gonna make is we're basically gonna make a form. We wanna basically bend a piece of metal over this half piece of tube. We're gonna use this larger half piece of tube, but I don't want this thing to deform that way, so I'm gonna basically make a brace structure over it with 2 braces going over. That's what we're gonna weld up today. So we're gonna design that. So the first thing I'm gonna do is get the diameter of the tube we're using, and it's 3.385. I'm going to use 3.4. So I'm going to go back to sketch. I'm going to sketch on that same plane. I'm going to hit the hotkey C, which is going to let me make a circle. I'm going to type in 3.4, and that is the radius of this thing. Now, this isn't a full circle because I cut it kind of so that it isn't half the circle. So this is going to take a quick measurement of how deep this thing is. And from top to bottom, I get 1.328, zero it out again. We just say 1.3. So I'm going to hit hotkey L for a line. I'm going to hit X, which turns on and off the construction lines. You can see over here as I hit that. And now I'm going to draw a line straight down 1.3 inches. And then from there, so I'm going to draw a line across here. Now this whole thing's, I'm going to talk while I'm thinking while I'm talking here, but it's 3¼ inches. So I want it 4¼ inches. So it's a ½ inch wider on each side. So I'm going to say hotkey L. I have the construction lines off. If I bring my cursor over to that point there, you can kind of see it makes a square. And as I roll out over here, it'll keep it in plane or in line with that. So I'm going to say 4.25 is the length of that line that I want. Now I want it centered on that point. So I'm going to go over to this top bar here, which are the constraints. I'm going to say hit this little center constraint. I'm going to say this line, I want it centered on that dot. And now it moves it so it's equal distance on that dot. From there, basically I know it's 1.3 to here. And I really probably want another inch of material above there to really make it strong. So let's just say I'm going to hit hotkey L. I'm going to go straight up 2.3 inches. Let's say 2.3 inches here. I'm going to hit hotkey L again. I'm going to go straight up 2.3 inches here and hit enter. And then I'm just going to connect these dots. And now this is the shape that I want, is this piece right here. I just got to cut a few pieces away from it. So I'm going to get the scissors out. I'm going to start cutting out stuff that I don't want in this shape. And that's the thing that I want to cut. Now, all of the load and all the work is going to be done right here. So there's no reason I can't probably fill up the ends over here just to make this a slightly cooler piece once it's all done. And hit OK. And that is the piece. Now I'm going to hit extrude. And this is also going to be a 1/4 inch plate piece. You can kind of see what that looks like. And I'm going to bring the other one back. Now I got 2 of these. They're superimposed. I don't want that to happen. So I'm going to... All right, so I have a piece of metal over there. Basically, that's 3 inches by 17 inches. I'm going to just draw another container here. I'm going to hit the rectangle container. So I'm going to hit hotkey R with the construction lines on, and I'm going to hit 17, and I'm going to hit tab 3. Now I know that all these pieces need to fit inside of this, which represents to me the piece of metal that's already sitting on my plasma table that I'm going to cut into. So now that I finished the sketch, I'm going to hit hotkey M. I'm going to go ahead and select the pieces that I want to cut. I'm going to start moving them into this shape. I'm going to hit enter. Now I want to make 2 of these, so I'm going to hit hotkey M again. I'm going to select the piece. I'm going to tell it to copy it, and then I'm just going to grab this arrow and pull it over. I need to basically nest it with about a 1/4 inch in between the pieces such that the torch doesn't overlap, and that looks good. And then a hotkey M one more time. I'm going to take this piece and I'm going to move it into position, and just perfect. There we go. There, so there's all the pieces that we're going to cut for this part. Now I'm going to go from computer-aided design, CAD, over to computer-aided manufacturing, which is a really cool part about Fusion 360, is that it has CAD and CAM in the same program. All right, so the first thing we're going to do is we're going to create a setup. I'm going to go ahead and select the pieces that we're going to cut, these 3 right here, and then the box point, I always start up here in the top left and I work my way down to the bottom right. And this point right here is where the computer is going to basically zero itself out on. And then I'll go ahead and name this thing. All All right, from there, we're gonna go ahead and do some cutting. The tool that we're gonna use, and I use this thing all the time, and I've been talking about this forever, I think 4 years now. I've been using razor welds, and a lot of guys use hypertherms. I do have a hypertherm on my Dragon A250 from Bentech, but on this thing, the razor weld has been doing amazing. All right, select the razor weld, and then the speeds I'm going to cut out are going to be about 55 inches. There's not much as far as like an entry and exit speed. I could probably slow it down just a little bit as we enter down to 45 inches per minute. I'm going to go ahead and select these 3 things that we're going to cut, and then I'm going to tell it where I want to enter at. You know, somewhere where it's non-consequential, like over here and right there. And the longer you can make this number, the better, because that makes it fire the torch. It starts cutting. By the time it gets the piece you're going to cut, it's already established in the cut. The hardest part for this thing to do is start and stop cutting. So you want to be established in the cut. So 0.3 inches should be pretty good. If I say okay, it's going to generate the G code here, and this is how it's going to cut this thing. And you can kind of see it's not overlapping with anything. I like that. I'm going to go ahead and say post the G code. Now, since I'm cutting into 1/4 inch plate, I'm going to change this number to a 0.3 second pierce delay. Everything else I use a 0.2 second pierce delay. And then I want to change the folder, Trooper, beam parts. That's actually exactly where I want it to go. Select folder, and I'll post it. And now we're ready to go to the Langmuir Systems Crossfire XR and cut this thing out.